again, Workplace 11. I apologize for the noise in the background. The dryer's going, but I want to get this done. I want to get that done. I'm doing them both at once. All right, today we got some new terms to talk about. 1.5, pitch, grade, and drop. So these are terms that are common in construction. And it actually turns out it's not really too much new. It's just different ways of saying the same things we've already talked about. So let's take a look at them. First, we'll start with drop. Drop is the difference in height between one end of an object and the other end of the same object. So for example, let's draw a very simple object there. There's my object. If I was interested in the difference in height between one end of the object, like this end, and the other end, this end, I'm not interested in how long the object is. I'm interested in the difference in height. I'd be interested in this height right here. Now, how far down should I go? I should go down until I reach this point right there. Oh, I didn't quite make it. Oh, darn. You get the idea. Oh, it's so ugly. So this right here, this is the drop. That amount right there is the drop. Now, wait a minute. Haven't we already talked about this distance before? Don't we already have a name for this? We absolutely do. This distance right here is also called the rise. It's exactly the same thing. Drop and rise are the same thing. So if you're doing construction and creating a driveway or something, you might use the word rise, but you might use the word drop like they do in this question. So let's do it. It says, the end of a driveway is 8 meters away from the house. In order for surface water to drain properly, because you don't want the water sticking around on your driveway, you want it to run off the driveway, right? The driveway must drop 14 centimeters over the length of the driveway. Find the angle of elevation for this driveway. All right, let's draw our driveway. We're going to draw it very simply. I love drawing simple math pictures. So something like this. It's probably exaggerated. That's pretty steep. Now what else do we know? This is here's the house up here. Uh-oh, now I got to really start drawing. Here's my house up here, right? Small little house, door, windows, chimney, another window. It's looking beautiful. This is the house, and this is the end of the driveway, right? The road is out here. Here's our road. Okay, so what do we know? The end of the driveway is 8 meters away from the house. So I guess the tricky thing about that is, if I was to make our triangle like this, we get our right angle triangle. This 8 meters, it doesn't mean that the driveway is 8 meters long. It means that the end of the driveway to the house is 8 meters. This is 8 meters. I don't know if I haven't written the question well, I haven't drawn it well, but that might be a bit confusing to you. I'll tell you that this is the 8 meters. I'll make that more obvious in questions we do in class. All right, in order for surface water to drain properly, the driveway must drop 14 centimeters. Remember, drop is just the same as rise. So where's the rise? Right here. This is your 14 centimeters. All right, if you don't mind, I'm going to get rid of my road, which is pretty awful, and I'm going to get rid of my house, which is totally awful. So what we need to do is we need to find the angle of elevation. Where's the angle of elevation? Well, remember from last day, angle of elevation is from the horizontal up. This is the angle we want, and I could put theta if I want to represent that. So how do we do that? Oh, it's just like we did last day. The first thing we want to do is find either the slope or what's exactly the same as the slope? The tangent ratio. Either one of those will do the job. Okay, if we do slope, what's slope? The formula for slope, it's rise over run. Rise, 14 centimeters, over run, 8 meters. Or if you're doing tangent ratio, remember it's opposite over adjacent. Opposite of this angle is right here, 14 centimeters, yep. And adjacent is right here, 8 meters, yep. Remember, this is not adjacent. This side up here is the hypotenuse. Okay. All right, so now we have the slope. Just get rid of the units, right? Oh no, we can't. How come? They're not the same. We want to have the same units. So we will have to do this sometimes. We'll probably do a specific lesson on this in the future. Switching from one to the other. So 14 centimeters, 8 meters. You know what would be simpler to switch to? It'd be easier if you switched them both to centimeters. You could switch them both to meters, but I think you'll find it easier if we switch them both to centimeters. So let's keep this as 14 centimeters. But let's change this, 8 meters. Now, do you know? Here's what you need to know. 1 meter, think of a meter stick that I swing around at the front of the classroom sometimes. You know how many centimeters there are in that? There's 100 centimeters in that. So if 1 meter is 100 centimeters, then how many centimeters is 8 meters? Hey, you know what you could do here? You could set up a proportion. You don't have to. I'm sure most of you already know the answer. But if you can't get it, you could set up a proportion. 1 meter is equal to 100 centimeters. We're interested in 8 meters. Where should I put that, top or bottom? Well, meters is on top, so let's put 8 meters on the top. And we don't know this one. Guess what we can do? Cross multiply. You go 8 times 100, that's 800, divided by 1. Well, divided by 1 does nothing, just keeps it the same. So 8 times 100 is 800. That is our answer. So we get for the bottom, 8 meters is 800 centimeters. I probably made that more confusing than I had to. I bet as soon as I wrote this, you knew this was 800 centimeters. Good, look, we have the same units. We can get rid of them now. So our slope, or our tangent ratio, is 14 over 800. Oh, let's put it in lowest terms. You could divide them both by 2. 14 by 2 is 7, and 800 by 2 is 400. And that's it. But do you remember what we often do with our slopes, our tangent ratios? We write as a decimal. So let's do that. 7 divided by 400 is 0.0175, and I'm actually going to put all 4 of those numbers because that'll make my answer better when I find the angle of elevation. And that's what we're going to do right now. We're going to find the angle of elevation. Now, how did we do that? What we did is we did inverse tan, right? Tan negative 1 is how you say inverse tan. So you're going to do inverse tan of the slope, or inverse tan of the tan ratio, or in this case, inverse tan of 0.0175, and it's time to go to that great calculator I used last time. Here it is. So remember, right now, you don't want to just hit tan. If I hit tan, it's going to be wrong. That's not inverse tan, that's tan. So let me clear that. I want to go inverse tan. In this calculator, you're going to hit this func button. For your calculator, you're probably hitting inverse, INV, or second, or shift. Those are the 3. And it's often in the top left-hand corner of your calculator, of all the buttons, top left. All right, so inverse tan is right here. And our number was 0.0175. That was the tan ratio, or the slope, as a decimal. So here you go. Here's our answer. It's 1.0025. I guess that's 1.003. I'll put that. 1.003. Basically 1 degrees, isn't it? But I'll put 1.003 degrees. And that is our angle of elevation. That's what this angle right here is. 1.003. That's a very small angle. Okay, our next term is pitch. Doesn't have to do with throwing a baseball. Doesn't have to do with how high a note is, right? Low pitch. High pitch. No, that's music. Pitch in construction is just the slope of a roof. It's literally the same as slope when you're talking about a roof. So you might hear someone talk about, oh, I'd like to get up on the top of my roof and clean off the leaves, but there's a really sharp pitch up there. It's a really steep pitch. All they're talking about is the slope. So guess how you find pitch then? Rise over run, just the same as slope we usually do. All right, so simple idea. Pitch is the same as slope, but here's actually a pretty challenging question. It says, how wide is the shed if the pitch on the left side is 3 to 4 and the pitch on the right side is 8 to 9? From here all the way over to there. That's what we're trying to figure out. Now, the good news is we already know part of it. We know that this amount right here is 3.2. So that's good. So basically all we have to do is figure out this L, that's an L there, whoa, figure out that L, add them together, and we'll have our answer. But how are we going to do that? Well, it turns out you got to look at the two sides individually. So let's start with the left side. So that is this triangle. So it tells us that the pitch on the left side is 3 to 4. Now remember, pitch is the same as slope. So what does the 3 refer to and what does the 4 refer to then? Well, slope is rise over run. So in other words, it's 3 as the rise and 4 as the run. But wait a minute, it's not actually 4, it's 3.2. What's going on here? Well, this is just like a lowest terms easy way of expressing it, and this is what it really is. So guess what we're going to have to do here? We're going to have to set up a proportion. So our proportion, our first fraction, is the actual slope, 3 to 4, equals, okay, this 3.2, where should I be putting that? Now be careful, this was rise over run. Is that number there a rise or a run? That's definitely a run, so that should go on the bottom. And what letter would make sense to put here? How about the H, since that's what we're actually trying to find? So you put the H right there. Time to cross multiply. How do we do it? We multiply this diagonal, can't multiply this one because we don't know the H, this diagonal, so 3 times 3.2, and then divide it by 4. So 3 times 3.2 is 9.6, and then I'm going to divide it by 4. H is 2.4. Okay, great. So we now know this amount right here is 2.4. And now we can work on the right-hand triangle there. So now I'm going to draw the right-hand side here. And what do we know in that triangle? We know that the pitch of this one is 8 to 9. Right angle triangle. 8 to 9. Again, this is the pitch, which is the same as slope. So this is rise, and this is run. So it rises 8, this is 8, it runs 9, this is 9. Again, wait a minute, it's not actually 8, it's 2.4, we just figured that. Figured that out. Well, that's because this is just a simpler form of writing the slope. So let's set up a proportion. Slope is 8 over 9, or rise over run. And then for the other one, we already know this 2.4, right? Is that a rise or is that a run? That's a rise. So we got to put the 2.4 on the top. Rise over run. Rise over run. What should we call this one? How about L, since that's what it says there? I'm not a huge fan of using L. Looks like a 1 or something, but I'll do it. So how do we get L? Cross multiply. 9 times 2.4, and then divide it by 8. 9 times 2.4 is 21.6, and we're going to divide that by 8. And 21.6 divided by 8 is 2.7. Nice. So now we know this distance is 2.7. Are we done? No. Remember, we wanted to know this whole red amount here. So how do we do that? Well, we know this is 3.2, and we now know this is 2.7. So to get the total width, I'll write that down, squeeze it in here. Total width is equal to the 3.2 plus the 2.7. I don't even need a calculator for this one. I don't want to show off, but I got this one. 5.9. 5.9 what? We're talking about meters. So 5.9 meters is your answer in that one. Okay, last term here, and the last term is grade. Nothing to do with your performance in this class. I'm sure you're doing great. High grade. But this is in construction. And a grade is the slope. It's just another term for slope. But with grade, you're usually talking about a physical feature such as a road, a hill, a railway, something like that. Now, there is one unique thing about grade. It's often, not always, but it's usually expressed as a percent. So I'm going to give you a little formula here for how you can get your grade. All you do to get your percent grade is you get your slope, your rise over run, turn it into a decimal by dividing, and then just multiply by 100. That's it. Okay? Let's try a couple questions. Dana is a plumber who is installing a hey, wait a minute. We got 2 of these tick marks. What's that mean? Last time when we had 1 of those tick marks, it meant feet. When you have 2 of those tick marks, it means inches. So, Dana is a plumber who is installing a 2-inch drainage pipe in a bathroom. The pipe must drop a 1/4 inch per foot to ensure proper drainage. How many inches of drop are there over a distance of 11? This one is feet, right? Because there's only 1 of the tick marks. This is feet. First thing, let's draw our pipe. Oh, red pipe. Okay. So we got our pipe, and it says the pipe must drop a 1/4 inch per foot to ensure proper drainage. Okay, and it's talking about the drop, so we're interested in this drop down to here. right? And it says it must drop a 1/4 inch. So what's another way we could write a quarter instead of writing as a fraction? I bet you'd be happy if we wrote as a decimal, wouldn't we? So instead of a quarter, what could we write? 0.25. 0.25 for every foot. So this is inches, and this is 1 foot. And what we want to know is how much drop would there be if it was a distance of 11 feet? Well, wait a minute. We could just do a proportion here, right? If it's dropping 0.25 inches for every 1 foot, and what we're interested in is how far does it drop over a distance of 11 feet? Okay, so we want to know the drop. We don't know the drop, so I'll put a D there for drop, but we know that the distance is 11 feet, and we want to find the D there. So we can just cross multiply. D equals, cross here, 0.25 times 11, and then divide by 1. Well, dividing by 1 doesn't do anything. If you multiply 11 times 0.25, you'll get 2.75. 2.75 what? Well, the top here was inches. So it needs to drop 2.75 inches. All right, what's the percent grade? Well, we've got our formula up here. You just need to find the slope and then multiply it by 100. Find the slope as a decimal and multiply by 100. So that's not too bad. Let's find the slope to start. Slope equals rise over run. So our rise is 0.25 inches and our run is 1 foot. And slope's a ratio, so we want to be able to cross out those units. Oh no, we can't. They're not the same as each other. So we need to switch either inches to feet or feet to inches. You know what's going to be easier? Feet to inches. So let's leave this one. And what you need to know, which you might not know, I would give you this information, is that 1 foot is 12 inches. Oh, well, it says 1 foot there. I can just replace it with 12 inches. You can cross off your inches. So there you go. You get 0.25 over 12. But remember what we want to do? We want to get as a decimal. I know you already have a decimal here, but let's actually divide it so we get 1 decimal rather than a fraction with a decimal. Ugh, that's horrible. So you're going to go 0.25 and you're going to divide it by 12. And if you do that, you get a pretty long decimal. I'm going to write maybe 4 decimal spots. I get 0.0208. Okay? So let's go back and look at our formula. What we have to do is get the slope, which we just did, and then multiply by 100. Oh, okay. So for our grade, all we need to do is take our 0.0208 and times it by 100. You know how to multiply by 100? You can do it on a calculator, or you can just move that decimal 2 spots to the right. 1, 2. The decimal is going to be after the 2. So it's now going to be 2.08. And don't forget to put percent. When you get a grade, it is a percent. All right, last one. A 13.4 kilometer length of railway track. Wow, that's long. Okay, now again, I don't think it's totally clear what they're talking about here. I don't think they mean that this is 13.4 kilometers. I think they mean that this is 13.4 kilometers down here. Like from the start of the railway track to the bottom of the railroad track, it moves over a horizontal distance of 13.4. So I'm putting 13.4 kilometers down here. I'm sorry, I would make that a lot clearer for you in questions we do in class. And it has a grade of 2.1%. Now, remember what grade is? It's just the same thing as slope. The only difference is it's expressed as a percent. Sure, it'd be nice if we could change that into a fraction rather than a percent. How do you do that? Well, think of what percent means. If you get 70% on a test, it's kind of like you got 70 out of 100. If you got 28%, you got 28 out of 100. If it's 2.1%, it's 2.1 out of 100. So there you go. There's your first fraction. This is your slope. In other words, this is your rise. This is your run. What are you trying to find in this question? You're trying to find the rise. So I'll put an R here. You're trying to find that amount right there. But look, we already know the run. So we don't know the rise, but we do know the run is 13.4 kilometers. And now we can cross multiply. How do we do it? We go R equals 2.1 times 13.4 times, I guess, and then divide it by 100. Definitely need a calculator for this one. You get 0.2814. But wait, that's kilometers. We want to switch it into meters. So we need yet another conversion. 1 kilometer is 1,000 meters. Hey, why don't we set up another proportion? If 1 kilometer is 1,000 meters, and we're interested in how much 0.2814 kilometers is, then we can get the amount right there. I'll call it x. How do you get x? Sorry, I'm squishing it in here. Multiply this, so that's 0.2814 times 1,000, and then divided by 1. Well, dividing by 1 does nothing, and multiplying by 1,000 moves the decimal over 3 spots. 1, 2, 3. It's going to be between the 1 and the 4. X equals 281.4 meters. We just switched it into meters. There's our answer. The rise, the drop, right? You could also call it the drop or the rise of the trade track has to be 281.4 meters. All right, everyone. New terms, some tricky questions in there, but we have done a lot of this before. Good luck.